Here's problem 1518. Suppose it were possible to drill a frictionless cylindrical channel along a diameter of the Earth from one side of the Earth to another. A body dropped into such a channel will only feel the gravitational pull of mass within a sphere radius equal to the distance of the mass from the center of the Earth. The density of the Earth is 5.52 times 10 to the 3 kilograms per meter cubed. G is given. The mass will oscillate with a period of... Alright, let's imagine what we got here. We've got the Earth, and we have a channel that we have dug from one end of the Earth to the other. And somebody, like you or me, are going to jump into this channel, and you're going to fall through this channel from one end of the Earth to the other. Now, as you're falling, the force of gravity is only due to that part of the mass of the Earth that is below your radius from the center of the Earth. All the mass above you is, in essence, going to cancel out. So the force of gravity is going to get less and less as you're falling into this channel. In fact, as you reach the center of the Earth, the force of gravity will be zero. You'll be weightless at the center of the Earth. So let's imagine what this force of gravity will be. By Newton's law of gravity, the force would be equal to negative g, your mass, times the mass of the Earth, over r squared, your distance from the center of the Earth. But we're going to write the mass of the Earth as the density of the Earth, which is mass per volume, times the volume of the Earth, which is 4/3 pi r cubed. That's because the mass of the Earth is going to be a variable, in this case as a function of r. And all this is going to be over r squared. So 2 of the r's are going to cancel out, numerator and denominator. And we are going to have that this force is equal to a negative g, mass, rho, density of the Earth, 4/3 pi, and all that times r. G, mass, density, rho, 4/3, and pi are all constants. So I can think of this as one big constant, k, times r. So essentially I've got that this force is equal to negative kr. So that's the Hooke's law, which describes the spring force. And so if we can describe this motion of you falling into this channel like one big spring located as its with its equilibrium at the center of the Earth, then we can describe the angular frequency as square root of k over m, and then the period as 2 pi over the angular frequency. So our angular frequency is the square root of this k over m, and the period is the angular frequency over 2 pi, over the angular frequency. So the period is going to be 2 pi times the square root of m over k. So that is 2 pi times the square root of your m over this k constant that we have right here. So that is going to be g times m times rho times 4/3 times pi. M's will cancel out, and we have then that the period is equal to 2 pi times the square root of 3 over g times 4 times rho times pi. All right, we know all these numbers. Let's try them out and see what we get. Let's start up here. So t is going to equal 2 pi times the square root of 3. G is 6.67 times 10 to the minus 11. Rho is 5.52 times 10 to the 3. And we have 4, and we have pi. So let's calculate what that is. I get 5,059.4 seconds. So the repetition period of you falling into this channel, like a spring, going there and back again, is 5,059.4 seconds. Or let's convert this into minutes. So let's divide it by 60. And what do we get? 84.3 minutes. So it'll be 84.3 minutes of an oscillation period there and back again. You could go to the other side of the Earth and back again in 84.3 minutes. In fact, to get to the other side then would only take you 42.15 minutes to get to the other side of the Earth. Just make sure you grab onto the railing on the other side, because you're going to fall back into the Earth, and if there's any friction along the way, you're going to slowly dampen your oscillation and eventually end up at the center of the Earth. You'll be stuck there, weightless at the center of the Earth, until somebody comes down and gets you, or somebody else jumps into the channel and hits you along the way. So anyway, this mass will oscillate in this channel through the Earth with a period of 84.3 minutes. Answer.